Welcome to this video about draft survey. Well, draft survey is used to calculate cargo loaded or discharge. If it is conducted in a right way, the accuracy can be within 0.5% of the cargo. Well, a draft survey involves careful reading of drafts, taking into account all the prevailing circumstances. Now let us first understand about hydrostatic draft. Well, draft at the center of flotation is called hydrostatic draft. The center of flotation is the point about which the ship trims. So here this is the vessel and this is the point here about which the vessel trims. So we can say the vessel trims like this at some point. So the hydrostatic draft is the draft at center of flotation, and this is very important because all the hydrostatic particulars like displacement, TPC, that is tons per centimeter, MCTC, that is moment to change the trim by 1 centimeter, LCB, longitudinal center of buoyancy, LCF, longitudinal center of flotation, KB, that is center of buoyancy from keel, and that is meta center, transverse meta center, and this one longitudinal meta center. So all the hydrostatic particulars in a ship stability booklet are tabulated against the hydrostatic draft, and that is the draft at a center of flotation. And center of flotation is the point where the ship trims. So if the vessel is at even keel, trim is 0 and the draft is the hydrostatic draft. So in case of even keel, it is pretty easy to find the initial hydrostatic draft. And from the table we can also find the initial displacement. If we look at this table, here suppose draft is 3 meter, we can find the displacement as 5478 ton. Similarly, if I have the initial hydrostatic draft, so I can easily find the initial displacement. Now if I have some cargo and I load the cargo like this, the ship goes like this. So I have final hydrostatic draft. And similarly, I can find the final displacement. All I know now that if I have the initial displacement and I add something, which is the cargo I have loaded, or subtract if any I have consumption, or I add something like if I loaded some ballast also or loaded some bunkers also, I have the final displacement. And this equation is very useful. I can easily find the quantity of cargo loaded with this equation, and that is the basic principle of draft survey. So our objective is to find the hydrostatic draft. Well, we need to read the draft from all 6 positions. That means on the forward port side and starboard side, midship port side and starboard side, and aft also port side and starboard side. The drafts are read to the nearest a centimeter, that can be seen. So these drafts are corrected to the center line. So if I have the port side draft and starboard side draft, so I need to take the mean of that. Similarly, if I have the port side draft of midship and starboard side draft of the midship, so I need to take the mean of that. And similarly to the aft draft also. Basically, we need to correct the observed draft to the center line. However, we have one more challenge, that draft marks are not exactly located at forward perpendicular, aft perpendicular, or amidship. Due to the shape of the vessel, they are slightly displaced sideways. So for example, here is the forward perpendicular. Well, forward perpendicular is a reference line, and the draft mark here, they are sideways displaced. Similarly, the aft perpendicular is also a reference line. The draft marks may not be located aft perpendicular but slightly displaced laterally, and the midship marks are also not exactly at midship. So we need to apply corrections accordingly. So the first correction is called stem correction, which needs to be applied to forward draft. So forward draft must be read precisely at a forward perpendicular.